Welcome to the Crazy Hat Chemist, so another video here on electrochemistry. Boy, I'm feeling the shock already. Bam! So balancing electrochemical equations number 4. So let's get moving here. So we're going to balance the redox equation below. So let's check this one out. We have HNO3. Everybody hopefully knows what that is. That is nitric acid. That is a strong acid. It is one of the 7 strong acids. It is an oxidizing acid as well, and that's why it's in this unit of balancing chemical equations. Then there's hydrogen iodide. Then there's NO, that's nitrogen monoxide. Then there's iodine, okay, that is a solid. And then there's water, okay? That's our equation. So the first thing that we need to do, just like in any balancing equation, is we need to write down what the oxidation numbers are for every single element there is. So hydrogens are +1, okay? Oxygens are -2, and based on the oxidation number of the 1+ for the hydrogen and the oxidation number for the oxygen at -2, we can derive the oxidation number for nitrogen, which would be a +7, okay? Hopefully that makes sense. The hydrogen is a +1, therefore, consequently, the iodide is a -1. Okay, oxygen is a -2, therefore the nitrogen in nitrogen monoxide is a +2. Iodine is an element in its standard state, and therefore it is 0. Hydrogen is a +1, and oxide is a -2. So therefore, I have labeled just right now all the elements in this equation. Now what we need to do is identify the 2 elements, or maybe just 1 element, but 2 elements of which change in oxidation number. And you should see that the nitrogen is one of them that changes in oxidation number, as well as the iodine that changes in oxidation number. So going from a 7+ to a 2+, that is a reduction in oxidation number. That's why this is going to be reduction half reaction. Going from a 1- to a 0, that's an increase in oxidation number, and that is oxidation. So now what we're going to do is separate out the 2 half reactions that we have. There is the first one, that's HNO3, produces NO, and then the second one, which is HI, produces I2. Okay? Now what we need to do is balance all elements first, except for the oxygens and the hydrogens. So I'm going to take that first top reaction, which is the reduction half reaction, okay, and balance the nitrogens. There's 1 nitrogen on the reactant side, 1 nitrogen on the product side. Okay, now there's an unbalance of the number of oxygens, and that would be the next element that I balance. There's 3 oxygens on the reactant side, and there's 1 oxygen on the product side. So I add an equivalent number of waters, that's H2O, to balance the number of oxygens that I need. And I need 2 oxygens, therefore there's 2 water molecules. Now I'm going to balance the hydrogens. On the reactant side, there was already 1 hydrogen, and I just added 4 hydrogens with that 2 coefficient in front of the water. So I have 4 hydrogens on the product side, 1 on the reactant side. I'm going to add 3 hydrogens on the reactant side. That's hydrogen ions. Now I've balanced this for mass. Now I need to balance it for charge. So on the reactant side, I have a 3 hydrogen ions, that's a 1+, so that's a total of a 3+ charge on the reactant side. On the product side, I have a 0 charge. So I always want to balance it by adding electrons such that both sides, the reactant and the product side, has a net charge of the lowest charge. It happens to be the lowest charge is a 0 on the product side. So I'm going to add 3 electrons onto the reactant side. Now my reduction half reaction is now done at this moment in time. Now I'm going to move to the oxidation half reaction. So the first thing that you need to do is balance for all elements other than oxygen and hydrogen. And on the reactant side, I have 1 iodine, and on the product side, I have 2 iodines. So I need to put a 2 stoichiometric coefficient in front of the HI. That will balance the iodines. Now I have 2 hydrogens on the reactant side and none on the product side, so I need to add 2 hydrogen ions onto the product side. The reactant side has a net charge of 0. The product side has a net charge of a 2+. I always go towards the lower of the two charges. So I'm going to add 2 electrons here onto the product side. So now both the reactant and the product side of the oxidation half reaction, the bottom reaction there, has a net charge of 0 on both sides. I want to point out another thing that I'm not sure if I have pointed it out, and hopefully you've recognized it, but you have to have the electrons on opposite sides in the two half reactions. After all, what we're trying to do is cancel out the electrons. And in order for the electrons to cancel out, they need to be on opposite sides. I didn't directly point that out, but I'm going to point that out right now. Now, in order to add these two equations up, I need to get rid of the electrons. That means when I add up these two equations, the reduction half reaction, the oxidation half reaction, the electrons must disappear. That means there must be the same number of electrons on both the reactant and the product side. So I need to multiply the top reaction, which is the reduction half reaction, by a 2 coefficient. I need to multiply the bottom oxidation reaction by a 3 coefficient. This will give me 6 electrons on both the reactant and the product side, and then I'll be able to add up the equations. So what we're going to do now is distribute that 2 on the reduction half reaction, distribute the 3 on the oxidation half reaction, and I'm going to get the following for the reduction half reaction. So I have 6 electrons, 6 hydrogen ions, 2 nitric acids, 2 nitrogen monoxides, and 4 waters. Okay, that is my reduction half reaction. My oxidation half reaction, I got 6 hydrogen iodides, gives me 3 iodine molecules and 6 hydrogen ions and 6 electrons. Okay, now we are noticing that we have a hydrogen ion in this reaction. Therefore, this reaction is actually occurring in an acidic solution, as noted in the very first part of this reaction where it was in nitric acid. Duh, that's an acid. So there should be hydrogen ions involved in this. Okay, sometimes they do cancel out, but what hasn't canceled out eventually here on this one will be the nitric acid. So there's still acid in here. So we're going to draw a line in the sand, if you will, and add up these two equations. In order to do this, the electrons must cancel. The 6 electrons must cancel on both sides. What also happens to cancel here are the 6 hydrogen ions. So you should see that the electrons cancel, and in addition to that, the hydrogen ions cancel. So I've simplified this reaction a little bit before I've actually added up my reduction and oxidation half reactions. Now, there's nothing else that I can simplify, and there's nothing else that I can combine together. So I'm just going to drop everything down according to where it's on the reactant or the product side. And then I have my balanced chemical equation right there. Okay, again, the last thing you do before you start labeling this is to make sure that you have everything balanced. On the reactant side, I have 2 hydrogens with the nitric acid, 6 hydrogens with the hydrogen iodide, for a total of 8 hydrogens. On the product side, there are 4 water molecules. That's 4 times 2, that will give me 8 hydrogens. I have 2 nitrogens on the reactant side. On the product side, I have 2 nitrogens. In terms of oxygens, I have 6 oxygens on the reactant side and 2 NOs, that's 2 oxygens on the product side, and 4 waters, that's 2 plus 4, in a total of 6 oxygens. In terms of the iodines, I have 6 iodines on the reactant side and 3 times 2, that's 6 iodines on the product side. It's most certainly balanced. Okay, and now you can label this. Okay, I have the reduction reaction, which is what is being reduced, and the oxidizing agent is the nitric acid. What is undergoing oxidation and is the reducing agent is the hydrogen iodide. Again, the labels always go with the reactants, never the products. I am the crazy hat chemist, and of course I got myself a crazy hat, as I always do, and I got this from a student, and I'm not sure if it's really a crazy hat, but it's just a cool hat, so thank you very much. I appreciate that. If you enjoyed that video, please give me a thumbs up. That really truly helps me out. If you enjoy many of my videos, then please subscribe to my YouTube channel. In addition to that, please pass on my YouTube channel to anybody that you know that needs chemistry help and assistance. You can find me and my website and then donate to the cause and get yourself a sticker or maybe even a t-shirt. Next time we're going to do some more balancing equations of redox reactions. I'll see you next time. Bye for now.